some mathematical basis to music as well, tabla, for example.
Yeah, definitely.
So what is the connection? These are like very tough for me to understand, maybe others do, but what is the connection?
Well, in tabla is all about rhythms, time cycles, trying to fit various pieces into a rhythm cycle.
Right.
And so the arrangements that one practices as a tabla player uses a lot of mathematics. One example that I always start with in the class that I teach, just to get people to realize that mathematics is connected with poetry and with music, is an example of Hemachandra. This is always one that I start with because it brings in tabla and poetry and mathematics right away. So in Sanskrit poetry, there's a notion, there are two kinds of syllables. There's a notion of a laghu syllable and a guru syllable. How many people have heard of laghu and guru before? Yeah.
That's about 5%, 10%?
Yeah, so I mean that's one thing I feel should be there in math class.
Yeah.
This is
Exactly.
The notion of laghu and guru is something that led to some of the most fundamental breakthroughs in mathematics, believe it or not, in ancient times in India. So there's a notion of laghu syllable and a guru syllable, a short syllable and a long syllable. So in every kind of poetry in the world, there's a notion of stressed syllable and unstressed syllable. When you say poetry, some syllables are stressed, some are unstressed. In Sanskrit, it goes a step further. The stressed syllables are long, the unstressed syllables are short. And the short syllables take 1 beat of time to say, a long syllable takes 2 beats of time to say. So what's peculiar about Sanskrit is that a long syllable takes exactly twice as long to say as a short syllable. Oh. So when you recite Sanskrit poetry, all the syllables will be like this. Some will last 1 beat of time, some will last 2 beats of time. The short are 1 beat, the long are 2 beats. And so this is very peculiar about Sanskrit, and as a result of the setup of Sanskrit poetry, lots of ancient poets considered lots of mathematical questions that related to this 1 beat, 2 beat setup of Sanskrit poetry. So one basic question that would come up: if you're writing poetry and you have 8 beats left in your stanza, and you need to fill it with long and short syllables, where a long syllable takes 2 beats and a short syllable takes 1 beat, how many ways can you fill in 8 beats with long syllables and short syllables, where a long syllable is 2 beats?
Don't give us the answer. Anybody know?
What would be your guess?
Oh wow, come on.
By permutations and combinations?
It is about permutations and combinations, but it's sort of beyond what we learn in school. What would be a guess? So 8 beats, filling it with longs and shorts. Long 2 beats, short.
And 4 short beats.
No,
and
how
2
many
long
variations
how
can you
many
have?
ways could you do it? Yeah. So you could do long.
That's
right?
4
That would
longs,
do it.
yes.
You could do short,
8 times, yeah.
short. Or you
And
could
then you can
do
go
short, long, long, short, long, right? You could do. So I actually do these. I clap these rhythms with my class, and we go through and we try to figure out how many there are. Mm-hmm.
Sorry, say it again.
Fibonacci number, 8th Fibonacci number.
That's the 8th. Yeah, so he knows the answer. So this.
You just went straight above my head. I don't know.
The answer is 34. So most people, when they first hear this question, they would think, oh, maybe there are 8 ways, 10 ways. The answer is actually 34, which is more than most people expect.
Most people would have thought, yeah.
And in this ancient Indian work of Hemachandra, which I read to the class because it's written in poetry, the answer.
Right.
So it's a poetic question. It's a question about poetry, and the answer is written in poetry. So it's something that really excites people. It excited me when I was a child, so I like to share it, and it really excites students. And so Hemachandra's answer was as follows. He says, write down the numbers 1 and 2, and then every number you write down subsequently should be the sum of the previous 2 numbers that you wrote down. So 1, 2, and then 1 plus 2 is 3. Then 2 plus 3 is 5. Right. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34, and so on. The 8th number that you write down will give you the number of rhythms that have 8 beats, which was 34.
Wow, that's amazing, actually.
And this goes back to the year 1050. So these numbers may be familiar to many people, right? They're called the Fibonacci numbers in India, even though in India they were discovered pre-Fibonacci by Hemachandra in this work on poetry, which I find really amazing. So when we're taught Fibonacci numbers in school, maybe this is true in India as well. I've definitely seen in some Indian schools, they teach it the way Fibonacci came up with it, which is about this problem about rabbits. It's this incestuous problem about rabbits where brothers and sisters are mating, and it's a very unnatural kind of... But the real place where it came up was actually in poetry. And the reason that it came up is a very natural one. You need to know the answer if you want to know how many ways you can fill in the rest of your poem if you have a certain number of beats left. So that's an example of the kind of way that mathematics came up in poetry in ancient times and still comes up today when people compose Marathi poetry or Kannada poetry.
Right.
The setup of poetry is very similar in those languages as
And
well.
it